Hello, my name is Elise Chase, and I'll be presenting our work, In Touch with Causation, Understanding the Impact of Kinesthetic Haptics on Causality. Humans use causal relationships to learn about the world, and touch plays a large role in exploring these causal structures. However, much research on causal perception has focused on the visual domain following Michat's seminal work. Later research has shown that the addition of audio feedback increases the range of causal perception. Work that has incorporated haptic feedback into causal perception considered whether causal events prime the user to feeling a force, which leaves the question, how does the addition of haptic information change the perception of possibly causal events? To study this, we use the classic Michatian launching paradigm in which a moving launcher, the blue train, contacts a stationary object, the red train, at which point that object begins to move. We designed a custom device to provide the desired haptic feedback. Users grasp the device and their hand is moved along a single axis with a constant force that is synced to the motion of the second train. The ordering between haptic and pure vision trials are counterbalanced between participants. In addition, we manipulated the temporal offsets between when the launching train arrives and the second train begins motion. There are a total of 6 negative offsets, 6 positive offsets, as well as a 0 offset condition, which are repeated 12 times and presented randomly to the user. At the end of every trial, participants are asked what occurred, selecting either the causal or non-causal statement. We generated 4 psychometric curves for the positive and negative offsets in both the visual, pink, and visual and haptic, blue, conditions. The temporal offsets are shown along the x-axis, while the y-axis indicates the probability of a causal response. When we look at just the positive offsets, the addition of haptics affected participants' judgments. The probability with which participants view an event as causal for positive offsets was significantly greater in the vision and haptic condition compared to vision alone. Our results indicate that kinesthetic haptic feedback can alter people's perception of causal events in cases with temporal delay. To understand what salient haptic information is used to form these judgments, we plan to explore other types of haptic feedback, such as vibration. Additionally, to discover the specific role haptics may play, we also plan to make comparisons to other sensory modalities such as audio. Overall, with this research, we hope to uncover whether the effect haptics has on causal perception is unique to touch, and how people use haptic information to make higher level judgments about events that occur around them. Thank you.